Hello and welcome back on this sunny morning in August 2023. Today on the bench is the big green amp, and we'll continue on the subject of amp testing. So to recap, what do we need to test for output power? We need a signal source going into the amplifier. We need a meter to read the output in RMS, volts RMS, and we need an oscilloscope. You could do it without an oscilloscope, I guess, but it's a bit guesswork. So we've got a waveform displayed on the tech oscilloscope. You can see that's starting to clip there. I'll zoom you in. Turn the intensity up a bit. So you can see we're starting to flatten off there. Come back there, and we are reading 13.54. Don't leave the amplifier on at these high outputs for too long. So you've got your so we need a calculator then to calculate it, or you could do it in your head or on a piece of paper. So what do we have? 13.5. So we need to square that. 13.5 times by itself, which is squaring, times by 13.5 equals 182. Then we divide that by our load. In this case it's 8 ohms. Divide by 8 equals 22 watts. And that's how you test for output power. Let's see if we can do that without the oscilloscope. So we've got the meter there on the right channel. I mean, we don't know there, do we? We don't know what the waveform is doing. We could keep going and we just might bugger the amplifier. 16, and as you can see, that is no good. We've got crossover distortion and clipping. The amplifier ain't gonna like that for too long, and it's only with an oscilloscope that we can see our true reading, although we've got 13.6 here, and on the HP audio analyzer 13.7. It's about the same. So to test for hum and noise, all you need is an AC meter. As mentioned previously, it has to be able to test, well, it should be able to test for 50 Hz, 100 Hz with no input. So what we got there, 0.005 5 millivolts hum and noise. If we look at the oscilloscope, put it on the lowest range, you can see we've sort of got something very small, isn't it? The HP 8903B reads the same, 5 millivolts, 5.6 in this case. So in this case we've got hum and noise 5 millivolts, and we had 22 watts output power. However, you need to qualify that 22 watts at 1 kilohertz. So next we're going to test for input sensitivity, and for this we've got a bit of a different setup. We've got the HP 8903B with a 1 volt 1 kilohertz signal going into this pot. I think it's a, I don't know, 100k pot. We've got the volume controller of the right channel to maximum, full whack, and we have our fluke reading the wiper of the volume pot. So all we need to do to find out the input sensitivity, we need to turn this 100k volume pot that we've got jerry rigged here, keep turning that until I read 13.5 volts here, which means we've got 22 watts. And then we take that reading there. Here we go then. So I've got 0.122 or 122 millivolts. I've got 13.7, which is about a 22 watts. I mean, if you wanted to do this more accurately, you would do. I'm trying to cut down the time. And we've got a nice waveform displayed there. So I'm going to turn that down now. So our input sensitivity is 0.122. Right, so we should write that volt, shouldn't we? Should write it correctly. Sorry for that. 0.122 volts for 22 watts output at 1 kilohertz. To test frequency, we're going to be using this 6V6 single-ended amplifier, just to give you a quick, rough sort of way of testing frequency. You can see the scope there, and you can see the meter there, which is telling how many volts we've got output. I'm just going to reduce that until it sort of stops clipping. So the first thing you do is you set your frequency to 1 kilohertz. Adjust your scope, and then you adjust your time base until you've got, so adjust your volume control until you've got a nice sine wave that fills all of the screen. In this case it's just a little bit over, but it's filling all of the divisions, the graticule. That's 1 kilohertz, and as you can see we've got 1.7%. Oh sorry, 1.7 volts RMS. Then to do a quick frequency test, to have a rough idea of what it's like from low frequency, say 100 kilohertz to 20 kilohertz. So we dial in frequency 100 hertz. Adjust our time base, and as you can see it is still filling all of the screen, all of the graticules. So we know that it hasn't dropped significantly at that frequency. So basically that's 0 dB. From 1 kilohertz to 100 hertz it's 0 dB flat. Next we're going to change it to 20 kilohertz. Frequency 20 kilohertz. So as you can see, at 20 kilohertz it's still, we're about 2 divisions smaller. We've got 1, 2, 3, 4, 5, 6 divisions. So I'm just going to increase the frequency 25 kilohertz. Still not quite, but if you see now, we're roughly half as big as it was at 1 kilohertz. So this is a quick way of testing your frequency response. So now we know that at 100 hertz it's the same, 0 dB, as it is at 1 kilohertz, but at 25 kilohertz it is about half as big, meaning it's 3 dB down. 3 dB just means half as big, half as much power. There we go. So that's a quick way of testing your frequency response. That's a quick look at a few more parameters concerning amplifier testing. In the next one we'll go into frequency response testing in a lot more detail. Thanks for watching, bit of a short one this. Take care of yourselves. Ta-ra for now.